Where's my y-intercept, ladies and gentlemen?
Negative 1.
I can do that too. Up or down?
Down.
Are we going to plot this with a solid line or a dotted line?
Solid.
Why solid? Are you sticking with me here?
Mm-hmm.
See the solid line? Solid line says, oh, solid line right there. Solid line. So, we temporarily set it equal. We cover up everything except the x to find the x. We cover up everything except the y to find the y. Don't have to do anything here. Have to just divide by negative 4 there, you get negative 1. X, 4. You got it. Y, negative 1. You have 2 points. You only need 2 points to make a line, don't you? Make your line. And then we do, we're done? If you don't shade these things, do you have the right answer?
No.
What you've done here is you've graphed this. I want you to graph this. Okay, that's a big difference there. This you did in maybe even Math 8 or your pre-algebra. You did this. We're here. The only other thing is you got to shade it, but you do have to shade it. So you're going to write out check. And you're going to tell me the point that you are checking. What point are you checking here?
0.
If it doesn't go through the origin, check 0, 0. That makes an entire side of your standard form equation 0. We like that. So we're checking that point. So we're going to have 0 minus 4 times 0 is less than or equal to 4. So 0 is less than or equal to 4. So you got to be able to tell me whether that's a true statement or a false statement. What do you think?
True.
Is 0 less than or equal to 4? Absolutely. Yeah, that's definitely true. 0 is less than $4, right?
Yeah.
Definitely true. Well, here's what we did. We just checked that point. So know the point that you checked. Did this point work?
Yes.
If this point works, that means every point on this half plane is also going to work. You follow me? Try some if you want. Try 1, 1. 1, 1 is going to work. 1 minus 4, oh, that's negative 3. Negative 3 is less than 4. That's going to work. Every point is going to be just the same on this side. Every point over here is not going to work. None of these things are going to work. So are we going to shade the, we'll call this the top. Are we going to shade the top or are we going to shade the bottom?
The top.
Definitely. It worked. We shaded the side of the half plane that that point is on. We're going to shade this whole thing. By the way, a couple things I want you to notice the difference here. Will the points that are on the line work in this inequality?
No.
On the line?
Yes.
Yes, because it's solid. Will the points on this line work in that inequality? No, that's the difference, okay? The open circle or the dotted line means you can't actually get to those points. You get right up to them. The solid line or the solid circle means you can. So these points will work in that inequality. How many people want to show what we talked about today? Good for you. So when we're doing our graphing linear inequalities, our first idea is, well, we want to make sure we temporarily set this thing equal to 0. That way we can find our x and y intercepts and graph at least the line part of it. However, we know that we're not just graphing lines here, we're actually shading a half plane. So it's either going to be shaded at the top half or the bottom half of our graph, and that's telling us our whole solution set. So the first thing we're going to do, let's set this thing equal to 0 temporarily. By the way, do we ever do this any other time besides right here? The only time you're ever going to switch an inequality to an equal sign is right here. We'll do our 3x plus 2y equals 12 just for a second, and this is just so that we can find our x and y intercepts. Ladies and gentlemen, in order to find the x-intercept, what do I do? Good, okay, so if I want the x's, I better cover up everything except the x's. That makes sense. So that's gone. I'm just going to rewrite what's left. So x-intercept, we cover that up, we write what's left over, that's 3x equals 12. And there's at most one step. There's at most one step after covering up in order for you to find the intercept. In our case, what is that step? Yeah, we'll do that. Divide both sides by 3. And all of a sudden we have our x-intercept, and that's 4. Not so bad. So here's our x, here's our y. Here's what we know already. If we just found our x-intercept, we just found where our graph is going to cross the x-axis. That's this one. Where's it going to cross the x-axis? Yeah, it tells us. So we're going to go over to 4. And we'll put a point right there. That's how you use your x-intercept. You just put it on the x-axis. That's half of your graph right there. You only need 2 points, right? We already have one of them. Now, let's go ahead and find the y-intercept. What do we do in order to find the y-intercept?
X equals 0.
Good, and setting x equals 0 means we're just going to cover that up. If we want the y-intercept, let's cover up everything except the y. One thing on this, make sure if you're going to cover up everything except the y, I know that's a plus sign, it really doesn't matter in this instance, but don't cover up the sign, because if that was a minus, that would change our problem. We saw it last time. You with me on that? So cover up just the x term and write what's left over. So we have a 2y equals 12. We'll do the same process we did for the x-intercept. That's just divide both sides by 2. We get y equals 6. If y equals 6, that means, well, are we going to go up or down on the y-axis? Good. Put a point there. Hey, you only need 2 points to graph a line, right? We've got 2 points. Let's graph our line. This way's harder. Do it this way. It's harder. I don't know why. The other ones this way look good, look great. Those ones have a little kink to it. Wait, what now?
Dash.
Why?
Not equal to.
Okay, so why is this not right? What would solid represent?
Equal to.
Yeah, the solid would represent equal to, because it would mean that the line is actually included in our solution set. It means that we could go up to the line and actually include the line. If we're not equal to, it means the line itself is actually not included. We can go all the way up to the line, but the line itself is not in our solution set. So in order to represent that, if we do not have an equals, remember, we're not looking here, right? That was just a temporary step, just for like 5 seconds, so you could write your x and y-intercept. We don't ever use that again. We look back up here that says it's not equal to, so I definitely need a dashed line, or a dotted line, either one. And we're done, right?
No.
Why are we not done?
You gotta check it.
Okay, we have to check 1 point because, yes, we have to shade it. We've got to shade half of this graph. Either the top half, we'll call this the top half. Either the top half is going to be shaded, representing all these points, or the bottom half is going to be shaded, representing all those points. One of those halves is going to work. What point do we always like to check, ladies and gentlemen? Okay, can we check 0, 0 here?
Yes.
Yeah, absolutely. As long as it's not actually on the line, you can check it. So we're going to write down here, check. We're going to put the point that we're checking. In this case, of course, we're checking 0, 0. Now, where do you check 0, 0? Do you check it in your original inequality, or do you check it in this equation? What do you think?
Original.
Yeah, this was just for a second. We're using that one. So check that point. We have 3 times 0 plus 2 times 0 is greater than 12. It's nice because this right here, this makes one whole side of our inequality equals 0. That's why we use that point if we can. 0 is greater than 12. What do you think? True or false? Definitely false. Well, here's what that said. If we checked 0, 0 and it was false, did that point work in our inequality? Are any of these points going to work in our inequality?
No.
Okay, so are we going to shade, let's call this the bottom, are we going to shade the bottom half, or are we going to shade the top half? If this point doesn't work, none of these work, all of these work. We shade that. Go ahead and give that a try with that example. So I want you temporarily setting that equal to 0, equal instead of inequality. I want you to find your x and y intercepts, graph them on an xy axis, use the appropriate type of line, check your point and shade. That's the whole process. Good, lots of good work so far. So see X and Y intercepts, see the appropriate type of line, and some good shading. We're going to start up here in just a bit. Okay, so the first thing I hope you did was temporarily change that inequality into an equal sign. What that lets you do, only for one reason, we're just finding X and Y intercepts with that. So we'll say 3x minus 6y equals 12 just for a second. We'll cover up some appropriate things to find the appropriate intercepts here. So if we want to find the x-intercept, which we'll do first, we're going to cover up the y term. That means we're plugging in y equals 0. That's really what we're doing. We're just going to write the rest. By the way, would this still work if that number wasn't divisible by 3? What if that was like a 16? Is that going to be okay?
Yeah.
You just have 16 thirds, that's going to be 5 1/3. You can still graph that on a graph. That'd be okay. So we divide both sides by 3, and we get x equals 4 again. Now for our y-intercept. Same idea, we still want to set our x equal to 0 this time. That means cover up our x term, not with the negative covered up, without the negative covered up, because this sign goes with this term. So we're going to cover this up and do negative 6y equals 12. Did you all do that?
Yes.
How many of you got your intercepts of 4 and negative 2? Good, that's fantastic. And we can start graphing this. So we know we cross the x-axis at 4. We know we cross the y-axis at negative 2. Our lines are going to intersect with both those points. Do I need to make that a dashed line, or do I leave it solid in this case? Good, that's worth a couple points on your test. You know that that's a solid line versus a dashed line. It's pretty easy to tell, right? We just go right up here. If it's equals, keep it solid. If it's not, make it dashed. We check one point. If it's not on the line, we're going to check 0, 0. It's the easiest one to check. So over here we put check 0, 0. And what we're doing is essentially plugging in 0, 0 for our x and our y coordinates. So, let's see. True or false?
True.
Definitely true. If it's true, you shade the side that the point you just checked is on. You shade that half point. So 0, 0 worked. It represents all these points work.